Welcome children. In this video we will see the introduction of quadratic equations. According to our CVS syllabus, this is the fourth chapter. This chapter is not new actually. The term quadratic is not new to you in fact, because in chapter 2 you have learned about the polynomial and especially the quadratic polynomial. So this is the extension of that only. So the term quadratic is very familiar to you. So here, unlike polynomial, we will see equations. Okay, so equation you did in previous chapter, chapter 3 as well. So there you learn different methods of solving linear equations. So here in this chapter also we will learn different methods of solving this quadratic equation. So this chapter is very important in the sense this is applicable to different parts of mathematics and even science. During calculation you need this concept of quadratic equation and solving this equation. Okay, so today in this video we will just see the introduction part of this chapter. Okay, and in slowly we can go to the other part of this chapter later on. Okay, so quadratic equation. So first we will see the definition of this quadratic equation. It's very simple. Quadratic means having degree 2. No? So in polynomial you learn polynomial of degree 2 is called quadratic polynomial. So there only you have seen quadratic polynomial. There you learn zeros of quadratic polynomial. So for a quadratic polynomial there are two zeros. Okay, and degree 2 zeros 2. The same way here we will see instead of that zero here we will use the term roots of quadratic equation. Okay, so let's see the definition first. So definition is, so we define it as any equation of the form px equal to, we know px already you did in chapter 2. This is polynomial. Okay, equation. Now this polynomial now we are using in terms of equation because equal to sign is there. So px equated with 0. So this becomes an equation. So any equation of the form px equal to 0 where this px, okay, where this px is a polynomial, px is a polynomial of degree 2. Okay, so this px is polynomial of degree 2 is known as quadratic equation. Okay, so this is how we define quadratic equation. So an equation of the form px equal to 0 where px is a polynomial of degree 2 is known as quadratic equation. Okay, so if we see the example, if we want to see the example, we have so many examples. Like we can write 2x square plus 7x minus 3. This is, we know, this is a well-known polynomial of degree 2, means it's a quadratic polynomial. Now when we equate this with 0 we get quadratic equation. Okay, now so after knowing this equation, now let's see the standard form of quadratic equation. So let me write here an equation of the form ax square bx plus c equal to 0 where or A, B, C. Okay, this A, B, C are real number. So this has to be real number, otherwise we cannot solve. And the most importantly, this A, the first term, A should not be 0. Okay, so this type of quadratic equation, all right, this type of quadratic equation where A is not 0 and ABC must be real number. Okay, this they must be real number. So is known as standard, known as the standard form, standard form of a quadratic equation. So this is how we define standard form. So this form, wherever we find, we see, we consider that as a standard form. Okay, now, so once we know this quadratic equation, now let's see that roots means zeros. Zeros in case of quadratic polynomial, we used to say zeros. Here this is an equation, so we use the term roots of a quadratic equation. Quadratic equation. So as we know, the meaning of zeros already we learned in chapter 2. So here just the name only is different here, roots, meaning is same. So this is nothing, it is something like value, number. If I take this one, this equation, quadratic equation, then if I substitute the value of x, okay, and after substituting that value here, and when I solve this left hand side, I must get 0. Okay, so that is the meaning of roots of the quadratic equation, means that any value which makes any value of this variable x, variable can be x, y, z, anything. So unlike linear equation where you learn two variables, in this chapter only one variable will get x or y or z, like that. So the value of this variable which makes this left hand side 0, because both sides should be equal, 0. So that value of x is known as roots of quadratic equation. Okay, roots of that particular quadratic equation. So here we can assume, suppose let me take a real number. So remember, we will deal with real number only. So a real number, suppose if I take alpha, real number alpha is a root of quadratic equation, and let me write in that standard form, ax square bx plus c equal to 0, where we know a should not be 0. If now what we will do is we'll substitute this x by this alpha. So this x will be replaced by alpha square plus b alpha, only that x we are replacing by this alpha, because we consider this alpha as the roots of this quadratic equation. So this equal to 0. Okay, so what I wrote here, when I keep this alpha here in this x, I must get both sides equal. No? So if that is true, then we regard this alpha as root of the quadratic equation, this equation. Okay, so we can write so any real number which satisfies a given quadratic equation. Given quadratic equation is called the root or roots, whatever, of the quadratic equation. Quadratic equation. Okay, this is how we define root of quadratic equation. Here satisfies means when we substitute that real value in place of x, both side, left hand side and right hand side must be equal, means left hand side should be 0, 0 equal to 0. That is called satisfies here, satisfying here. So this is known as root of this quadratic equation. Okay, so this is how we define root. So if let's take one example. Suppose if I have a quadratic equation x square plus 2x plus 1 equal to 0. If this is one quadratic, this if is a quadratic equation in x, then now if I consider a value for x and after keeping that value in place of x, okay, if I get left hand side 0, that means this whole term, if it becomes 0, then that particular value which I will take for x, that value will be called root of this quadratic equation. So we can easily tell here, if I take x as minus 1, okay, if I take x as minus 1 or plus 1, I don't know, that's just I kept here, let me change the equation, x squared to x and this one. Yeah, so then x equal to minus 1, let's use minus 1 here, let's see what we'll get. Then x equal to minus 1, or we can write here taking, just I took randomly x equal to minus 1 here. What we get? We get, see, we get x will be replaced by minus 1. Okay, so x square means minus 1 square plus 2x is minus 1 plus 1. Let's see, minus 1 square is plus 1, and this 2 into minus 1 is minus 2 plus 1 equal to 0, and see 1 plus 1, this whole will be, see, now this x equal to minus 1 satisfies this equation, okay, this equation, because I got 0 equal to 0. So therefore x equal to minus 1 satisfies the given equation. Hence we can say x equal to minus 1 is the root of the given quadratic equation. Okay, so this is how we write or we find roots of quadratic equation. So this is how this we can say this x equal to minus 1, because this, when I keep x in place of x, when I keep minus 1, I got both sides equal, means this satisfies the equation. So minus 1 is the root, we can consider that as root. Okay, fine. Now comes the next one, and one more thing one must remember. For a quadratic equation, there are two roots. Okay, there are two roots. These roots are denoted by, we use alpha and beta. This we have done in chapter 2 as well. Okay, so alpha and beta we consider as two roots of quadratic equation. So this thing we will see more, we'll see this thing later on in more detail. So next we'll let me write here solution of a quadratic equation. Solution of a quadratic equation. Okay, so solution, again we know what is the meaning of solution. This is well known to you, makes no difference here. Means whether I should explain you or not, this is known to you. So let me write, so solving a quadratic equation, short we can write EQ, equations. Solving a quadratic equations means, a simple meaning, finding the roots of the quadratic equation. Okay, so the simple meaning of solution of quadratic equation. So finding roots. So we have not learned how to find the roots, that we'll do little later, but the meaning of root I explain here, and the solution of quadratic equation means that is also known to you. Now let's see quickly some examples regarding this quadratic equation. Okay, so quickly we'll see some examples here. Examples means how to check whether the given equation is quadratic or not. It's easy if you see, in most of the case it is very easy to identify, but in some cases you need to understand whether that is quadratic or not. So let me write here, check whether the following are quadratic equation. Okay, so suppose this is one question, let me write here, let me keep some equation, x plus 1 by x equal to 1. Number 2, x square plus 2 root over x plus 1 equal to 0. Number 3, root over 2 x square 7x plus 5 root over 2 equal to 0. Number 4, x plus 3 by x equal to x square. Okay, this 4 examples are sufficient. Check whether the following are quadratic equations. So we have to check here whether these are quadratic or not. So many times when we see, we can easily make out whether it's quadratic or not, but sometimes it is difficult unless you solve it, unless you simplify it. Okay, so let's try to do. Number 1, we have x plus 1 by x equal to 1, right? So this we can take, see, this is in rational form, so fractional form. So we know how to do simplification here. So we'll take LCM, x into x square plus 1 equal to 1. So if I go further, I'll get x square plus 1. This x will cross multiply with 1. X into 1 is x. And then finally, x square, this x will come this side, minus plus becomes minus, plus 1 equal to 0. So this is what we got. Okay, and if you see here, degree of x is 2. Degree of this equation is 2. So since degree is 2, second order, therefore it is a quadratic equation. Simple. Now number 2 was x square 2 root over x plus 1 equal to 0. So when you see this equation, in our first go, when we see this in our first glance, it looks like quadratic because degree is 2. It's not wrong to say that degree is 2, but in spite of having degree 2, this is not a quadratic equation. Why? Because problem is here. This is the problem in this equation. So you have learned this thing in polynomial even in class 9, that any expression where we get this root irrational variable, okay, this x is the variable here. So if we get something like this, or any variable with non-integer power, non-integer, okay, try to understand, non-integer power. So power should be non. If variable of that expression contains non-integer power, then such polynomial expression are regarded as not polynomial. They are not polynomial. Okay. So remember, for an expression to be a quadratic equation, first thing it must satisfy the condition for polynomial. So if we get this kind of expression, this is not a polynomial. Okay, it's not a polynomial. It's not a polynomial. So non-integer, you know, in non-integer means what? X to the power 1 by 2, x to the power suppose minus 3, x to the power 7 by 2. So this type of thing, when we get this type of expression, that means that is not a polynomial. Okay, so that's why here if you see this one, root x is nothing but x to the power 1 by 2. See, 1 by 2 is not integer. This is rational number. Okay, that's why I said if power is not non-integer, then that is not a polynomial. So since root x this is, no, see, this one is not a polynomial. So in spite of having degree 2, this is not a quadratic equation. So since this is not a polynomial, therefore it is not a quadratic equation. Try to understand again. Degree is 2, but still it's not quadratic equation. Why? Because to be a quadratic equation, it must be a polynomial. Unless it is a polynomial, that expression cannot be an equation. Okay, so that's why this is not an equation. Why? Because this expression is not a polynomial. Okay, so that's why equation 1, 2, 3, 4, 5, 6, 7. So that's 8, why 9, 10. It's not a quadratic equation, we can say. So it's not a quadratic equation. Okay, so likewise, if you go to number 3, next question, root 2x square 7x plus 5 root 2 equal to 0. See, if you see here, this x square degree 2, second x has power 1. So this is clearly, since it has degree 2, therefore it is a quadratic equation. Done. And if when we talk about fourth number, x plus 3x equal to x square, we can easily tell. Okay, take LCM, x square plus 3 by x. Okay, so yeah, now we can easily tell, easily find out. X square 3, and this x will cross multiply with x square. So x into x square will give you x cube. So we don't need to arrange here because we can see x cube power 3. So since degree is 3, no, degree highest power is 3, degree 3, therefore it is not a quadratic equation. Done. So this is how we can check whether or not the given equation is quadratic equation. Yeah? So simple that way to find it out. Okay, so this is the introduction of this one. So in our next class we will see some more regarding this quadratic equation. Okay.